Hi, this is your Sapil Bharti, and we are back with our yearly video production series. And today we have with us once again Simon Ritter, Deputy CTO at Azul. Simon, it's good to have you back on the show.
Good to be back. Thank you very much.
It's my pleasure. Before I ask you to share your predictions, please quickly remind our viewers what is Azul all about and the core problem you folks are going to solve as we head into 2026.
So we are a company that's focused purely on Java. So it's not about writing Java applications, it's about Java runtimes. And so the problems that we solve are basically if you're running Java applications and you want a supported Java runtime, then your options are fairly limited. What we can provide is a low-cost alternative to people like Oracle, who are the main provider. The other thing that we do is providing a high-performance Java runtime, and some of what we'll talk about in the predictions will be related to that in terms of how performance is very important if you're looking at cost and cloud cost optimizations and so on. And we've just recently acquired a company called Payara who do Java runtimes for Java Enterprise. So if you're writing Jakarta EE applications, then we can provide a runtime for that as well.
Excellent. Thank you. Now it's time for you to grab your crystal ball and share your predictions with us.
Right. Yes. So we do have a number of predictions. The first one that we've got is that Java becomes the glue of enterprise AI. And what we really mean by this is we're looking at trends rather than the idea of something particularly radical. We're looking at trends, and what we're talking about here is the idea that when we deal with enterprise applications, it's very much looking at high performance because we need to be able to scale out to very large workloads when we're dealing with the sort of internet-sized workloads that people have. And Java's been around for 30 years now, and it's proven its ability to scale into those very large workloads. That's why people use Java for those types of things. I mean, a great example of how that kind of came about, using an example, is Twitter. So before it was X, it was Twitter. And Twitter was originally written in Ruby on Rails. They used some other sort of languages and stuff like that. But once they found that they started to really take off and they were getting much bigger workloads, they said, actually, we need something that's going to perform better. So they didn't necessarily rewrite it in Java. I think they used Scala to start with. But it was a language that ran on top of the JVM. And it was the JVM that gave them that scalability. So this is what we're talking about in terms of seeing more of that as we move into 2026. Java's already very, very popular in the enterprise, but it's really going to become the glue that sticks things together. And that really extends into the idea of AI, because, again, AI, very popular, lots of people want to use it for different things, but if you talk to people about what programming languages and what platforms they're using for AI, it tends to be Python. But the thing about Python is it's very good for data sciences. It's very good because you can learn to program in Python quite quickly, but it lacks that scalability. One of the key things that we see with Python is it has a thing called the GIL, the Global Interpreter Lock. What that essentially means is that you can only do one thing at a time. So if you're trying to handle lots of connections, lots of people trying to use your system at the same time, then you're going to run into a problem because you can only do one thing at a time. With Java, we've spent 30 years developing the platform and making sure that it scales well by allowing you to do things concurrently. There's lots of different approaches that we have built into Java in terms of multi-threaded concurrent applications. One of the most recent ones was the idea of virtual threads. So now that rather than mapping a single Java thread to a platform thread, an operating system thread, we now map multiple Java threads to a single platform thread, and that gives us even better scalability. So that's the kind of thing that we talk about when we think about the glue of enterprise AI or enterprise applications, is that ability to scale up and deliver on the performance that people need. If we look at our second prediction, we say AI will accelerate compute demand for Java workloads. Again, this is the sort of thing where you sort of think to yourself, well, hang on, people are using Python for Java, Python for applications in the AI space, so how does that increase the need for Java workloads? But the reality is that if you think about how we're going to apply AI, it's most likely that what you want to do is take existing applications where you've got these large data sets, you've got these interactions that people already have with that data, and you want to then build on top of that with AI type applications. So if you're going to build more applications on top of that, that's going to drive much greater need for running those Java workloads, because we're going to have more extraction of information, more extraction of value from it, more data that we need to process. So that's very much where our second prediction is coming from. Third prediction is also related to that AI kind of thing, and it's AI-assisted vibe coding will explode, but enterprise Java developers will be more critical than ever. And I think this is a very important thing to look at, because a lot of people have predicted that with the rise of AI, and specifically generative AI using large language models, we've seen an increase in the number of systems which are being developed to create software and do it from natural language prompts. So if you look at things like Claude or Copilot, they allow you to specify what you want your application to do. You write a description of it, and then it will generate the code for you. Now, that's really good. You think to yourself, great, now I don't have to have a software developer. I can just tell the system what I want, and it will write the code for me. Wonderful. Except it's not quite as easy as that, because especially when we're dealing with enterprise applications need to do exactly what you want them to do. And the problem that I see in what we're seeing in this prediction is that AI-driven coding using vibe coding is going to be very difficult, because if you're using natural language is inherently ambiguous. And I use a very simple example to demonstrate this. If I give you the phrase, the chicken is ready to eat, what does that mean? And now, it could mean that there's a live chicken on the ground who's hungry. But it could also just as easily mean that I've put a chicken in the oven and I've cooked it and it's now ready for me to eat. Both of those interpretations are quite valid, but they have very different meanings in terms of what you want to do with that phrase. When it comes to vibe coding, we need to find a way of very specifically, very precisely specifying what the code is going to do. That's why we have programming languages, because they're unambiguous. So that's the whole idea behind that. So I think vibe coding is going to be less important for enterprise application development. We will, however, very much see AI coding being used in enterprise applications, but not for the whole application. We're going to see greater use of AI in terms of IDEs, where people are coding, and it will do predictive code, where you type a line of code and then it will guess what the next line of code is likely to be, and that will make people more efficient. Similarly, if you want to create components, you can use AI to create a class or a part of a library. So it's a way of developing things more quickly. So I think that AI-driven coding is going to make developers more efficient. It's not going to do away with them completely. Fourth prediction is around application modernization, and we're going to see a shift from what we call cloud migration to Java modernization, and that's going to be driven by cost, risk, and again, AI demands. What we really mean by this is that we've seen over the last few years there's been a real trend of moving applications from running in a data center on premises to moving them into the cloud. The reason for that is around cost saving. People think that if we move from running it in a data center to using a utility-based pricing model where you only pay for what you use, you don't need to provision all the machines, you don't need to provision the hardware, the networking, and so on. So you're avoiding all of that cost associated with it. Move it to the cloud, only pay for the instances that you need, only pay for those instances when you're using them. That's great, we can reduce our costs. Problem is that we've seen a lot of people who've simply taken the approach of what's described as lift and shift. You take the application as it's running in your data center, you simply move it into the cloud and run it on an instance rather than your machine. Problem with that is often the way that applications are designed doesn't lend the architecture particularly well to using that utility-based pricing model, and you end up with a situation where you're over provisioning, you're keeping instances running far too long, and it actually costs you more than if you run it in your data center. What we need to do is see that Java modernization, moving away from monolithic applications to microservice architectures where we can break up an application into a number of discrete components, have those run in individual containers, have those run on individual instances, and then we can adapt that dynamically as workload increases. If we've got a particular part of the application that's causing a bottleneck, we can spin up new instances of that particular part of the application, redirect the load across those instances, and address the need. But that makes much more sense than trying to scale up an entire application in a monolithic structure. So we can see that moving away from simply saying, okay, let's move to the cloud and save money, what we need to do is look at, we've moved to the cloud, how can we optimize the applications that we're running in that cloud to get the best possible return from that? Linked to that as well is what we've described in terms of what Azul does, is thinking about if we can run the same workload on a smaller instance of the cloud, then we can save money. Give you an example of that. If you're running something like a Kafka cluster, where you're doing lots of message processing and you've got a certain number of transactions per second that you need to handle, you provision a certain number of instances for your cluster, you run your application. If we can improve the efficiency of the Java virtual machine underneath that, because Kafka runs on Java, you can handle the same number of transactions per second with less nodes in your cluster, or smaller instances, or both. Smaller instances, less instances means you're paying less for running the same cluster and running the same transactions per second. So that kind of thing is very much what we're talking about in terms of that prediction. I think the last prediction that I'm going to talk about today is how we're going to see a sort of convergence between DevOps and FinOps teams around the cloud return on investment per application, and looking at that in terms of a core metric. What we're talking about here is that we have obviously the DevOps team. These are the people responsible for deploying applications. They're responsible for making sure that the applications deliver the service level that people need, handling that number of transactions per second to support the number of users that you have. And we've seen a growing number of organizations who start up a FinOps team, which is focused on how to get the best possible return on investment, how to reduce costs, looking at where specific things are causing bottlenecks or causing additional costs that could be reduced. And I think what we're talking about in terms of that prediction is merging or converging those two teams together, so they work much more closely to really look at, when you're deploying new applications, when you're running existing applications, how can we get the most from that in terms of the performance, in terms of the reducing cloud costs, and making sure that you're getting the best return on your investment. So I think those are the things that I talk about during this presentation, and then if you have questions, I'm happy to kind of address those.
Now, thanks for sharing these predictions. What do you think are going to be some of the biggest challenges or bottlenecks that organizations will face this year?
I think what we're looking at is, again, it sort of comes back to the whole idea of AI coding. And I think that organizations are going to have to adapt to the use of AI in the creation and the maintenance of their applications. How they do that is really going to affect how successful that is. Because as I already said, in terms of the predictions, what we're going to see is people are going to need to understand how AI can be useful, but how AI can also lead us down the wrong path. And so when organizations are looking at using AI coding, they need to come up with a comprehensive and cohesive strategy for applying that to make sure that they're getting the best results from it, rather than simply creating, we talk about AI slop as, things that are generated which are really rubbish. You don't want that if you're generating enterprise applications, mission critical applications. So you need to be very careful about how you're using AI. And I think that's something that's really going to happen in the next year.
These challenges, or any challenge, it also leads to opportunities. What are some of the opportunities that you see will arise this year?
Yeah, I think the opportunities are in terms of those cost savings. I think that there's lots of places where organizations need to think about the amount that they're spending on provisioning a particular application. And often I talk to customers and I talk about the possibility of reducing costs for things, and sometimes they're less interested in that than I expect them to be. And I think that from an opportunity point of view, that's really important, because when you're looking at the kind of current economic climate, most organizations are looking at how to cut costs because of inflation, how can we cut costs in different ways? And if you can focus on your IT systems, if you can think about how to reduce the costs whilst delivering the same level of service, then I think that's a real opportunity, because as a, let's say, a DevOps person, or even the CIO level, if you can demonstrate general cost savings, then that's going to really kind of help your organization, your business, to thrive. And I think that's a real opportunity that people are going to have.
What is your actionable advice for enterprise leaders? What should they start doing now to be ready?
Yeah, I think that there's several things that you need to look at. One is, in terms of those cloud deployments, what is the architecture that's being used? So are you working in terms of a microservice architecture? Are you still using monolithic applications? Do you need to think about re-architecting? Once you've done that, what can you do to improve the efficiency? What can you do to improve the performance of your applications through either changing the code, eliminating dead code, writing new code, or improving the performance of the existing runtimes and so on. So I think all of those things are very important in terms of delivering those things.
If I may ask you, what is going to be your as well as Azul's focus or priorities this year to help customers navigate this future?
Yeah, I think that from Azul's perspective, not a lot is going to change, because we've always focused on how do we reduce people's costs, either through the support costs associated with Java, reducing that by eliminating the need for Oracle licensing, through using our high-performance Java to reduce the number of instances and so on that people need. But I think for us, the big change this year is because, as I mentioned, we've acquired Payara as a company, and so that's expanding the area that we can address in terms of enterprise applications. There are a lot of people out there who are using enterprise Java. Again, Java's 30 years old. Enterprise Java's not much less than that. I think it goes back to 1998, so it's about 28, maybe 27 years old. So there's lots of people out there using enterprise Java and what is now called Jakarta EE. So I think that what we're going to be focusing on is helping existing customers of Payara and also potential new customers to understand how it is that we can use that in combination with the things that we already do at the Java runtime level to optimize their applications and, again, deliver better return on investment, reduce costs.
Simon, thank you so much. Just stay on the camera, please, for a few minutes. Simon, thank you so much for joining me and share these predictions with you. I didn't want to put any pressure on you, but we'd love to have you back on the show at the end of the year to check how many of your predictions turn out to be true and to get a new set of predictions. But I really appreciate your time today. Thank you.
Great. Thank you very much.